It can't be a square. It's a non-square rhombus, yes. So if you want to do a square, that's different. So in other words, we're doing the most generic one. It's true that a square is a rhombus, but what you're going to try to do if you're doing rhombus is do a rhombus that's not a square. All right? So think about all the things it has to be. Do you have a list somewhere? See, I think yesterday maybe you didn't write down enough stuff as you were going along. Yeah. All right, so, excuse me, which one are you going to do?
We just proved it.
Rhombus.
You're going to do a rhombus?
Yeah.
Okay. And do you understand that it's a not square rhombus?
Yes.
Okay.
We just got it.
You just got it? You're excited?
You guys want to do two-column proof or
Right, A, B, C, D.
Alright, let's find. I can name angles.
But what if she tells us that we don't know what a parallelogram is? Whatever, just say we know what a parallelogram is.
Okay.
So a rhombus is a quadrilateral that is a parallelogram with all congruent sides.
Yeah.
Exactly. There we go. So then, now let's prove it. Jerry? Alright. Wait, we need to name them first. Name each side A, B, C, D, and then and in the midpoint E. Okay. So then two column. Do we have given? What's given? The angle
that they are like
perpendicular to each other, right? That's it. That's all. That's all that's given. They're perpendicular. That BEC is a right angle.
Wait, hold on. AB is congruent to BC is congruent to CD is congruent to DA.
No, I think we need to prove that. We don't know that yet.
No, but that's...
Are those...
No, we don't. We're proving that it is a rhombus. Not if we don't. If we already know that these are all congruent, then it's like it's already proved. Then all we have to do is prove that they're parallel.
Wait, what's given though?
Given, I think the only thing that's given is these two with the diagonals. Like we say, like the diagonals are only. So you say AC is perpendicular to BD. That's given.
So AC is perpendicular to
BD. That's given. And 2AE is congruent to AEC, and then that BD is
congruent to EC.
That's given. And then BE is congruent to AD.
Is congruent to ED.
So now let's prove the triangle. Do we have to prove? Yeah, let's prove the triangle.
So then we know. Wait. So we have side angle side, right?
Side angle side. So we know that all triangles are congruent.
So they should be all like
So all the triangles are
perpendicular.
congruent?
All triangles should be congruent.
Wait, we know that like
so
these
if they're
are all right
perpendicular,
angles?
yeah, you said that AC. So if they're all perpendicular, then they're all right angles, and then so let's say BEC, triangle BEC is congruent to triangle DEC, yeah, because of side angle side. And then if triangle BDC, so then BDC is congruent to BAD by side, right?
Yeah.
So there we go. Let's prove that.
So it'd be triangle BEC
is congruent to triangle DEC,
and then that's because of side angle side,
and then for 5 is triangle BDC. No, wait. Can we just jump to that conclusion? That this whole triangle.
So we know that like these are congruent, right? So these sides have to be congruent.
Yeah.
And then they share this side. Right?
They share that. So then.
So how would we write that?
So let's write EC bisects. No, we already know that. We already know EC bisects BD.
Yeah, so it'd be like, how do we say that like BC is congruent to DC?
Because we already can. Okay, say that BC is congruent to DC.
Oh, should we
by
just write over here?
Right? BCTC.
Okay, so
CPCTC, right? Yeah.
Wait. BC is congruent to DC because of
CPCTC. And then now we have to prove. Wait, first say we prove these.
Alright. So number 6 is triangle BEA is congruent to triangle DEA because of side angle side, and then BA is congruent to DA because of CPCTC.
And now, how do we prove that all the sides are congruent to each other? No, then we'll say that the triangle.
Since these two triangles are congruent because of side.
So then, let's prove this first. So triangle BAD is congruent to triangle BCD.
Triangle BAD is congruent to triangle BCD.
Wait, which are we proving first? The sides or the
triangles?
Wait, how do we know these sides are congruent to each other?
We have to prove it like this. Okay, wait.
We're going to prove alternate interior angles first.
First or second?
First, because it's easier.
But these aren't necessarily parallel.
Yeah.
So there can't be alternate interior angles.
No, but these are supposed to be parallel. It's supposed to be like this. It's supposed to be a parallelogram.
Not necessarily.
But it's supposed to be. Listen, it's supposed to be.
No, because like a rhombus could also be like this.
But are these parallel? A rhombus has to be. Look at the definition. A quadrilateral that is a parallelogram. What's a parallelogram? Two pairs of opposite parallel sides, and it's all congruent though. So that's why a square can also be a rhombus because they're all congruent sides and they're both two sets of parallel sides. That's why. So then, wait, how are we gonna approach it then? We have to change. We have to get. Okay, what do we have to do? We have to prove that all the sides are congruent, and we have to prove that alternate interior angles are congruent too. So how do we?
Wait, why do we need alternate interior?
To prove that the lines are parallel. To prove that the sets of sides are parallel.
But we already know that it's a parallelogram. Oh wait.
That's the definition though. We just need to prove it.
So how do we do that?
Where are we at right now? Wait. BA, DA. So then.
So we prove that these two are congruent and these two are congruent.
Quadrilateral has 4 congruent sides, then opposite sides are parallel, diagonals perpendicular, 2 sides are
Okay. Let me look at this. You know, since you have barely started, I would love it if someone would do a kite. Would you mind?
Okay.
So kite is
Pretty much the same thing.
it just doesn't have as much. It doesn't have the parallel. It has in which two pairs of adjacent sides are equal. And so I think we don't have anyone with a kite. So a convex quadrilateral in which two pairs of adjacent sides are equal. What does that mean?
It means that these 2 sides are equal, these 2 sides are equal, but all 4 sides are equal.
Okay. Now, do you have notes on what the diagonals look like? Okay. You guys are so disorganized. What am I going to do with you?
Oh, here's the kite.
Oh, you got it? Okay, good, Tiana. Oh, that's good. Okay. So what did we have here?
So we have 2 long ones.
Okay. The diagonals are perpendicular. Okay. And so why don't you think about how those are different from that?
Okay.